80%. One company, China. 80% of the cranes lifting containers at American ports were built by ZPMC, Shanghai Zhenhua Heavy Industries Corporation, a state-owned enterprise controlled by the Chinese government. Not 80% of one type. 80% of every crane that matters. The massive ship-to-shore cranes, standing 140 feet tall, weighing 2,500 tons, lifting 40-foot containers off vessels from Asia and stacking them onto trucks bound for Walmart and Amazon. Every iPhone, every car part, every pallet of medicine, all moved by equipment Beijing controls. February 2024, Congress investigates. The House Select Committee on the Chinese Communist Party releases findings. 200 ZPMC cranes operating at U.S. ports, only 92 inspected for security vulnerabilities. 108 cranes never audited, installed, plugged into port networks, running with full access to logistics data, shipping schedules, cargo manifests, container tracking, all flowing through systems ZPMC built, and in many cases, still monitors remotely from servers in Shanghai. Investigators found cellular modems hidden inside crane control cabinets, capable of transmitting data over Chinese mobile networks, even when the port's own systems were offline. Remote access backdoors, allowing technicians in China to log into crane software without notifying port authorities. Firmware updates pushed remotely by ZPMC, with no approval, no review, no documentation. Proprietary code modules performing unclear functions that could not be analyzed because the source was closed. If ZPMC can access these systems, it can monitor every container moving through American ports in real time. It can see what is being shipped, where it is going, who is receiving it, and how often. And because ZPMC is state-owned, that data flows directly to Beijing. This is not paranoia. This is infrastructure built by a foreign government, now embedded so deeply into the American supply chain that removing it would cost $150 billion and take more than a decade. You cannot replace 200 cranes overnight. You cannot rip out equipment that costs $15 million per unit and takes 2 years to manufacture. And you cannot run a modern container port without the cranes ZPMC sold you, because no one else makes them cheaper, faster, or in the quantities needed. The Port of Los Angeles operates 14 ship-to-shore cranes. 12 are ZPMC. The Port of Long Beach operates 13 cranes. All 13 are ZPMC. The Port of New York and New Jersey operates 33 cranes. 28 are ZPMC. This is the story of the greatest supply chain monopoly in history, and how it happened while no one was paying attention. 1999. The first ZPMC cranes arrive at the Port of Long Beach. Port managers are skeptical. Chinese manufacturing has a reputation for poor quality and unreliable performance. But ZPMC offers something no one else can match: price. A ZPMC ship-to-shore crane costs $12 million. The European equivalent from Krupp or Pacheco costs $20 million. Delivery time. ZPMC promises 18 months from order to installation. European manufacturers need 3 years. And quality. The cranes work. They lift 67,000-pound containers at speeds exceeding 600 feet per minute. They do not break down more than European models. When something does fail, ZPMC sends technicians within 48 hours instead of waiting weeks for parts from Germany. By 2005, ZPMC controls 20% of the US market. By 2010, 50%. By 2015, 70%. By 2026, over 80%. The same pattern repeats worldwide. Rotterdam, Europe's largest port, operates ZPMC cranes. Hamburg, Antwerp, Felixstowe, Singapore, Busan, all ZPMC. The company now controls 70% of the global market for ship-to-shore cranes and dominates every category of port equipment, from rubber-tired gantry cranes to automated stacking systems. Total installed base, over 10,000 cranes worldwide. The engineering explains part of the dominance. A ZPMC ship-to-shore crane is a custom-built machine standing between 100 and 140 feet tall, roughly the height of a 14-story building. The boom extends 210 feet outward to reach across container ships measuring 400 meters long and carrying 24,000 TEU. The trolley, riding along the boom, houses 4 Siemens 750 kilowatt AC motors, generating 3,000 horsepower combined. Wire ropes measure 3 inches in diameter, thicker than a human arm. The hoist system can lift a fully loaded 40-foot container, weighing 30 metric tons, and place it within 2 inches of target position, while compensating for 15-mile-per-hour crosswinds and ship movement caused by tide and current. Anti-sway sensors measure pendulum motion at 100 Hz and adjust motor speed in real time to prevent oscillation. The precision is extraordinary. Miss the target by more than 6 inches, and the container strikes the truck chassis or ship cell guide, causing damage measured in thousands of dollars per incident. ZPMC builds these machines at Changsing Island, a 5-square-mile industrial complex on the Yangtze River, employing 15,000 workers. Inside the fabrication halls, the air smells like ozone and hot metal. 10-kilowatt fiber laser cutters slice through 40-millimeter thick steel plate at temperatures exceeding 3,000 degrees Fahrenheit. The noise is deafening, 125 decibels measured at 50 feet. Workers wear double hearing protection and silver heat suits. Robotic welders join boom sections with 2,400 welds per assembly, each weld X-rayed at 150 kilovolts to detect microscopic cracks. A single bad weld in a critical joint can cause catastrophic structural failure when the crane lifts maximum load. Completed crane sections are lifted by overhead gantry cranes, rated at 400 tons capacity and loaded onto barges. The barges float downriver to the port, where specialized heavy lift ships wait. A single vessel, the MV Zhenhua 7, displaces 72,000 tons and can carry 4 fully assembled cranes stacked on deck. Each crane towers above the ship like a steel skyscraper lying on its side. The journey from Shanghai to Los Angeles takes 18 days. Once the ship arrives, floating cranes offload the structures, position them on dock rails, and connect power and control systems. First power-up happens within 72 hours of arrival. Full commissioning takes 2 weeks. From order to operation, 14 months. No competitor comes close. The control system is where the monopoly locks in. Every ZPMC crane runs proprietary software developed in-house at ZPMC's research center in Shanghai. The software manages motor speeds, load calculations, anti-sway algorithms, collision avoidance, and preventive maintenance scheduling. It communicates with the port's terminal operating system using standardized protocols, but the underlying code is closed source. Port operators cannot modify it, they cannot audit it, they cannot replace it without replacing the entire crane control architecture, a process costing millions and requiring months of downtime. When a crane breaks, the port calls ZPMC. Replacement parts are proprietary. Hoist motors, planetary gearboxes, hydraulic brakes, load cells, and programmable logic controllers are manufactured to ZPMC specifications and sold exclusively through ZPMC service channels. Third-party suppliers do not exist because the technical drawings are not public. Critical components have lead times measured in 8 to 12 weeks. If a hoist motor fails and ZPMC cannot deliver a replacement quickly, the crane sits idle. One idle crane reduces port throughput by 40 containers per hour. At the Port of Los Angeles, container dwell fees generate $300 per TEU per day. An idle crane costs the port $12,000 per hour in lost revenue, $288,000 per day, $8.6 million per month. Multiply that across multiple cranes, and the leverage becomes clear. If ZPMC stops supplying parts, American ports lose capacity within weeks. Ships queue offshore, waiting for berths. Carriers divert to Canadian or Mexican ports. Importers face delays. Retailers run out of inventory. Prices spike. The economic damage cascades through the supply chain faster than any port can respond. And there is no alternative supplier at scale. Cone Cranes, a Finnish manufacturer, produces high-quality cranes, but operates at 1/10 the capacity of ZPMC. An order placed today delivers in 2029. Liebherr, a German firm, focuses on niche applications and cannot supply the U.S. market in volume. Pacheco, the American company that once built cranes for the Port of Oakland, closed its shipyard in 1986. The infrastructure is gone, the workforce retired, the supply chains no longer exist. The security risk extends beyond parts. In March 2024, investigators analyzing ZPMC crane software discovered embedded modules communicating with external servers via encrypted channels. The traffic was intermittent, occurring during maintenance windows when port networks experienced low activity. Decryption proved impossible because ZPMC uses proprietary algorithms not documented in any public standard. When confronted, ZPMC claimed the modules transmitted diagnostic telemetry to improve reliability. Investigators could not verify the claim because the source code was unavailable. The possibility remains that ZPMC collects operational data from every crane it has ever sold, building a real-time map of global trade flows, more detailed than any intelligence agency possesses. The geopolitical implications are becoming impossible to ignore. If tensions between the United States and China escalate into sanctions or conflict, ZPMC could halt parts shipments, disable cranes remotely, or simply refuse to service equipment. Even without overt sabotage, withholding critical components would cripple American ports within 90 days. Hoist motors operate under extreme stress and fail regularly. Gearboxes require replacement every 5 to 7 years. Control boards suffer electronic failures from heat, humidity, and vibration. Ports maintain spare inventory for routine failures, but not enough to sustain operations if the supply chain is severed. A coordinated disruption targeting the top 10 U.S. ports would reduce container throughput by 42%, triggering shortages of consumer electronics, automotive parts, pharmaceuticals, and industrial components. Prices would spike within weeks. Manufacturing plants dependent on just-in-time inventory would shut down. The economic damage would exceed $300 billion in the first year alone, and recovery would take a decade because rebuilding domestic crane manufacturing capacity requires more than money. It requires steel fabrication facilities, skilled labor, supply chains for specialized components, and time to train workers and refine processes. ZPMC took 30 years to reach its current position. Any competitor needs at least 15 years to catch up. Congress proposed a solution. The Cranes Act, introduced in 2024, would require security reviews for all port equipment purchases and prohibit Chinese-made cranes at military or strategically important facilities. The bill allocated $2 billion for domestic manufacturing grants and port security upgrades. It passed committee with bipartisan support, but stalled in the full House due to concerns about cost and implementation timelines. Industry groups representing port operators opposed the bill, arguing that mandating expensive alternatives would bankrupt smaller ports unable to afford the premium. The Port of Virginia attempted to diversify by ordering 4 cranes from Cone Cranes at a cost of $70 million, 50% more than equivalent ZPMC units. Delivery is scheduled for 2029, 6 years after the order. Few ports can afford that price or wait that long. Meanwhile, ZPMC continues expanding. The company is building new factories, developing fully automated crane systems, and entering adjacent markets, including offshore wind turbine installation and heavy lift logistics. Annual revenue exceeds $8 billion. Profit margins remain healthy despite aggressive pricing, because government subsidies cover operating costs and state banks provide low-interest financing. ZPMC can afford to underbid competitors by 30% and still turn a profit. No private company operating under market conditions can match that advantage. The result is a feedback loop. Ports buy ZPMC because it is cheap. ZPMC gains market share. Competitors lose revenue and exit the market. Fewer competitors mean higher prices from remaining suppliers. That makes ZPMC even more attractive. The cycle continues until the monopoly is unbreakable. The dependence extends beyond the United States. Europe faces the same problem. Asia operates almost exclusively on Chinese equipment. The global shipping industry relies on infrastructure controlled by a single state-owned enterprise, accountable to Beijing, not to market forces or international norms. If China decides to weaponize that control, there is no quick fix. Ports cannot switch suppliers overnight. Cranes cannot be redesigned and built in months. Supply chains cannot be rebuilt while the economy is collapsing. The broader lesson is about hidden vulnerabilities in globalized systems. Most people never think about port cranes. They are invisible infrastructure, noticed only when something goes wrong. But they are as critical as power grids, water systems, and telecommunications. Without them, goods do not move. Ships do not unload. Stores run out of inventory. The economy stops. Allowing a foreign government to control 80% of that infrastructure was not a deliberate policy choice. It was the result of thousands of independent decisions made by port operators, prioritizing short-term cost savings over long-term resilience. The same pattern repeats across industries. Solar panels, batteries, rare earth minerals, semiconductors. In every case, production shifted to China because it was cheaper. In every case, dependence deepened until it became too costly to reverse. For now, ZPMC cranes will continue operating at American ports. The data will keep flowing to Shanghai. The dependence will keep growing. And every container unloaded will pass through equipment built, controlled, and monitored by a company owned by the Chinese government. Whether that remains a business relationship or becomes a strategic weapon depends on choices not yet made. But the window for action is closing. The longer the monopoly persists, the harder it becomes to break. And the cost of inaction, measured in lost sovereignty and economic vulnerability, grows every day.